Hello, my name is Caio Otoni. I currently hold a postdoc position at Professor Watson Law's group at the Institute of Chemistry, Unicamp, Brazil. Today I got a question for you. How small is small?
What is something small for you?
Could be an ant,
Can't you think of anything smaller than an ant?
maybe human hair.
Yes, that's true. Ants are pretty small, and human hair is even smaller. But let's consider cellulose, the most abundant biopolymer on Earth. We can make it 1,000,000 times smaller than an ant and around 20,000 times thinner than human hair. We're talking about nanocellulose, a specific class of cellulosic particles with at least one of their dimensions within the nanoscale, and that's tiny small. What about lightweight? What is light for you?
Maybe a cork or a styrofoam.
That's correct as well. Even though the density of cellulose nanocrystals and cellulose nanofibers is somehow big, we can also make it much lighter than a cork, with a density comparable to that of expanded polystyrene. The way to do it is by producing highly porous materials called aerogels. Unlike styrofoam though, these nanocellulose-based aerogels come from a renewable resource. That's what I would like to briefly show you here and in more details at the 255th American Chemical Society National Meeting. Eucalyptus fibers were bleached into commercial kraft pulp, which was then mechanically disintegrated to produce cellulose nanofibrils, or CNF. In this contribution, we report the production of CNF-based hydrogels, which were then frozen and freeze-dried into a renewable, porous, lightweight, high surface area aerogels. In addition to the features that I've just described, we are interested in producing multifunctional aerogels. To exemplify, we have been studying several strategies to provide these materials with antimicrobial activity. CNF was surface modified to retain a positive charge, to interact with a negatively charged bacterial cell membrane, leading to inactivation. This is one of the produced aerogels. After being compressed, they retain their final shapes until being dipped again in water, when they immediately recover their original shapes. The aerogels displayed a remarkably high swelling capacity, being able to absorb water masses up to 45 times higher than their original weights. In summary, if selected by ACS Brazil chapter in order to attend the ACS national meeting, I can ensure that this opportunity, if given to me, will be taken in a dedicated and responsible way in order to take the most out of this promising scientific event.